Okay, today we're going to start introing transformations, which if you did your homework last night, you're kind of knowing what to expect. You have done transformations before, but you've never seen the notation we're going to use. So that's really what our focus is how do we write transformations in a shorter way, and then applying that. This unit will continue second semester with Unit 5B, where we use what we learned this unit to help us with that next unit. So hopefully by now you've tried the warm-up. 1 and 2 should have been fairly simple, but number 3 is a little more challenging. And then as we go through this, I'm going to show you how we would write it with our notation. So the first one said move the graph 4 units to the left and 2 units up. So you probably counted from each point 4 units to the left, 1, 2, 3, 4, and 2 units up. So that point would have been moved there. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. And then one can connect. Ooh, not the easiest to write on this. And when we connect the points, and it looks like I literally just took that, translated it to the left, and then up. Another option you could have done, if you prefer, and this is usually what I start doing as we get more complicated. If I look at those points, -4, 6, -1, 2, and 4, 4 are the points of the original function. So here, here, and here. You could have also thought about it that way. So if I look, the point -4, 6 became -8, 8. The point -1, 2 became the point -5, 4. And then the point 4, 4 became 0, 6. So one thing that's nice about transformations is we're really just looking at patterns. So the first thing I'm going to look at is how did the x's change? So how can -4 become -8, -1 become -5, 4 become 0? All of those work if I subtract 4, which is really what to the left 4 units means. Then if I look at my y values, how would 6 become 8, 2 become 4, and 4 become 6? Those are all +2, which means 2 up. So we should see those patterns starting to happen. So when we try to write this, let's say this original graph was called f of x. Remember we say f of x, not fx or f times x. And we translated it to g of x, so that's where it ended. Because those are not the same, so I don't want to use f and f because that implies they look the same and they don't. One's shifted left and up. We would say g of x equals f of x plus 4 plus 2. And this would mean left 4, up 2. So really what we're going to practice, the transformations aren't challenging. What's more challenging is this new notation. So I want to explain where each piece comes from. So the first thing I'm going to look at is with the x. Do you remember when we had point slope form? We would ask ourselves what would make each side 0. So this would have been y equals 4 and x equals -4. So even though there's that +4 there, we had to worry about the opposite. The same thing is true when we go into function notation. So this actually means left 4. The up 2 will stay the same. Now, when I think about what's being changed, the left 4 was a change of my x's. It relates to the green, which is why it's with the x. So one of the first questions you're going to notice me asking every time is is the number inside the parentheses or outside? If it's inside the parentheses, it's going to change our x value because x is an input. If it's outside of the parentheses, it's going to change our output, which is our y. So since the 4 was inside parentheses, it's going to change x. And then since our our 2 is outside parentheses, it's going to change the y. And that's your first time seeing the notation, so if it feels a little weird, totally normal. Don't panic. We're going to practice this, and we really just practice for several days in a row. So, deep breaths. Okay. The next one was move the graph 4 units to the right and 2 units down. So again, we actually started with the same points. And all I did was take them and I moved them to the right 4 and 2 units down. So if I think about moving to the right is going to be along the x-axis. So that should be a change I see in my x's. So if I look, -4 became 0, 1, -1 became 3, 4 became 8. That is all adding 4. And then if I look at my y's, 6 became 4, 2 became 0, and 4 became 2. All of those are subtracting 2, which is my 2 units down. Which if I think about moving down on a graph, it makes sense that the y values are what's changing. So think about what we wrote before. Can you make a prediction of what this function notation is going to look like? It's going to look very similar. Same thing with my point slope. So inside will always be my change to the x. So my change to the x was going to the right 4. And I'm going to do the opposite just like point slope. Then outside will always be my y. So how did my y change? It went down 2, or I subtracted 2. So very similar, but it's telling us the direction that it's going to go. Now the next one was probably the trickiest. Again, we start with the same points. And now it said, shrink the graph vertically by half. So the first thing we have to digest is, what does it mean to be vertical? So if I look which axis is the vertical axis, it's, oh my gosh, that was bad. It's our y-axis. Oh, much better. Okay, so this is really saying shrink our y values by half. Well, if I'm shrinking something by half, all that means is multiply your y's by 1/2. So half of 6, so notice I'm not changing the x at all, since it says vertically. Half of 6 is 3. Half of 2 is 1. And half of 4 is 2. And then I just graphed those points. So -4, 3. 2 becomes -1, 1, and then 4, 2. The other way you can think about it is, what's the distance you have from the y-axis, and we're really just shrinking that in half. So the distance right now is 6. If I shrink that in half, it's 3. So same idea. Boom. Okay. So we talked about if it was inside, it's impacting the x. And if it's outside, we change the y. So since we just changed y by 1/2, that means I'm going to have a 1/2 outside of our function. So g of x. Now, what did we do with the 1/2? We multiplied, and whenever we multiply, we put that number in front. Like 2x. I wouldn't write x2. That's just weird. We don't do that. We put it in front. Same idea. And that's it. So it seems probably a lot more challenging than it actually is. And then we just practice. These are our 3 transformations we're going to focus on first. Is a horizontal shift, so moving left and right. A vertical shift, which is moving up and down. and then a vertical stretch or shrink. So let's think about the difference between stretch or shrink. Why would 1/2 be a shrink? Well, no matter what I multiply 1/2 by, it's going to get smaller. Versus if I had something like a 2, if I multiply 2 by something, it's going to become bigger. And that's just to start.